This is a video on graphs of log functions with a focus on transformations. As before, we're going to use f of x equals log to the base 2x as a parent function in this case. And of course, we know what f of x equals log to the base 2x looks like. It's this f of x function here. It's got the y-axis as an asymptote, and I've just labelled it here as f of x. And now what I'd like to do is graph g of x, which I'm defining as f of x plus 2. Now notice that I've got a bracket around this x plus 2, and so this x plus 2 is going to replace any x's in my parent function. So what I really want to graph is log to the base 2 of x plus 2. So first of all, I'm going to draw another table up here, and I'm going to put my values into that. So this time my table is going to look like this. I'm going to have my x for my inputs. I'm going to have my x plus 2 column, which is the actual value that I'm calculating the log on. And then I'll have my column log to the base 2 x plus 2, which is going to double up as my y column in my table. So I'm not going to actually start by filling in my x values just yet. I'm going to think about this a bit carefully for a moment and realise that actually I want my x plus 2 to be a power of 2. That'll make this log work out quite nicely. So whereas in this table, where it was just my parent function log to the base 2x, I put in 1, 2, 4, 8, 16 for x, because x was what I was calculating the log of. This time, where I'm calculating the log of x plus 2, I'm going to put those values into this column. So now I need to work out what the x should be. So x plus 2 is 1, so take the 2 to get back to x. So I'm going to have minus 1, 0, 2, 6 and 14. And I can just double check if I add 2, yeah, I end up with the correct value for that middle column. And then I want to just evaluate the log base 2 of the values in this column. Now I actually already have that information from this previous table. And those values are 0, 1, 2, 3, 4. Just watch out when you go to graph this particular function. I'm graphing using my x value and my output, my y value, or my calculation for log to the base x plus 2. So for example, I'm looking at the point minus 1, 0, 0, 1, 2, 2, 6, 3, and 14, 4. Let's plot those points now. So I've plotted these points, these positions, and now I'll join them together to create my function. So you can see what's effectively after happening is that I've taken my original f of x function and I've pushed it to the left slightly. And the amount that I've pushed it to the left corresponds to the value that I've added on to x. And specifically when we have a positive number in this position, we move in the negative direction on the graph for x. So we've moved negative 2 in the x direction when we have a positive 2 in our function. So a positive number makes us move left by that amount. So what would happen if we had a negative number then? Well, to find that out, we're going to graph h of x, which is f of x minus 2. Again, notice the x minus 2 is in brackets. So really what I'm evaluating here is log to the base 2 x minus 2. And again, I'm keeping the brackets around that x minus 2. It's replacing the x directly in that function. So to figure out what's going on, I'm going to go back up again and make a table. It'll be a very similar approach to before, and then I'll graph my points and we'll see what our new diagram looks like. So here I have my table. Again, whatever it is that I'm trying to find the log of, I'm best to use powers of the base for whatever I'm inputting to that. So it's x minus 2 that I'm getting the log of, so I'm going to use my powers of 2 in this column again. And of course now I need an x value that will bring me to this result. So if I take 2 off x, I end up at 1, so that should be 3. Let's just check. 3 minus 2 is 1, so that's fine. So now I have my x values, and of course my log to the base 2 x minus 2 values are actually fairly obvious from what's come before. And again, when I go to draw this graph, the points that I use are going to be the x value, so that very first column, and my result, my output, or my y, which is calculated on the basis of log to the base 2 x minus 2. So I'm going to go off now and plot those points and join it up and see what we have. So I've plotted my points and now I'll join them together. So here I have my function in blue, and you can see here again that the constant directly after the x is after influencing the position of the function. And this time my diagram, my function has moved right relative to the original parent function, and it's moved right by 2 spaces each time. So when I've got a negative value here after the x, I'm going to move horizontally, so in the x direction, in the positive direction by that amount. So a bit more generally, f of x plus c moves f of x c places in the negative x direction, Or we can just say if c is positive, move left by that amount. And when we have f of x minus c, move f of x, c places in the positive x direction. Or we can also say that if c is negative, just move your function right by that amount. And it's worth mentioning that the asymptotes move by the same rule. So, for example, if we look back to our function for g of x, which is our function in green, we can see that it is now approaching an asymptote of minus 2 on the x-axis, which I've just inserted here. And notice that the asymptote is minus 2 when I've added 2 to the function, or to the x value, I should say, really, there to be more correct. And on the other hand, with my h of x, where I've subtracted 2 from the input from x, I've actually moved the asymptote over across to 2. So it's important to take that into account. For the parent function, where it's just log to the base 2x, my asymptote is the y-axis, but the asymptote will move depending on what my constant is.